All right, so now we're going to start our lesson on factoring. And now we're going to factor our whole expression, x squared plus something times x plus something. So it's going to be that trinomial form, and we're going to break it up into two smaller binomials. Okay? To get started, though, we kind of have to go backwards and look at, okay, what were they starting out as in the first place? So here's what we had been doing earlier in the unit. We're taking two binomials, two terms that each have two parts to them, and we were multiplying them together. We were doing our double distributive. So x times x is x squared, x times 6 is 6x, 5 times x is 5x, 5 times 6 is 30. And then we always had to combine those middle terms together and got to our answer. Our goal now is to go from here back to that original form, to pull it back apart and separate it into pieces. So I'm going to do these next three real quick, and then we're going to talk about looking at what the answer looks like and what the original problem looks like. So here I have subtraction. So x times x is x squared, x times negative 2 is negative 2x, then negative 7x, and positive 14. So I got x squared minus 9x plus 14. For the bottom one, I have a plus and a minus. So I get my x squared, I get my minus 3x, I get my plus 4x, and I get my minus 12. And then I end up with x squared plus 1x minus 12. On the next one, again, I have a plus and a minus. So when I double distribute, x squared minus 6x plus 2x minus 12. Oh, not minus 6x, so minus 4x minus 12. So here's what I really want you to focus on, the signs of our answers. Okay? So when I had addition and addition for both binomials, my answer was both adding in the middle term and adding on that last term, because a positive times a positive gives me a positive last term, and then they were both positive, so they got added together in the middle. Where I have a subtracting and a subtracting, I'm going to get different signs. So I'm going to get addition for my last sign, because remember, a negative times a negative is a positive. But in the middle, I have a negative term and a negative term that combine to give me a negative. Okay? So we're kind of looking at what are those patterns in my signs that are going to help me figure out how do I want to set this one up. For the bottom two, this is where we have one of each. I have an addition and a subtraction in each of them. You'll notice, look at the last term, it's always a negative, okay? Because a positive times a negative is going to give me a negative. But the middle term can be different, depending on which of the terms was larger. In the first one, 4x was bigger than negative 3, so I got a positive one. In the second one, the negative 6x was bigger than the positive 2, so I ended up with a negative term. So if your last term of your trinomial is a negative, we know we had either a plus and a minus. We had different signs, because that's how we got a negative for our answer. If we have a positive as our last term, we know that both of our signs were the same. We just have to figure out, was it a positive or was it a negative? And we do that by looking at that middle term. I know that sounds complicated, but I want you to kind of see where it started and where it goes to, so we can kind of work our way backwards. So in our notes, we're going to fill in this top part. So think about what we just talked about. If the last term is a positive and the middle term is a positive, that means the two binomials I was multiplying were both addition. And then it's just a matter of figuring out what numbers go with them. If my last term is a positive, but my middle term is a negative, well, that means they had the same signs, but they had subtractions. They had negatives in them instead, because a negative times a negative would still give me a positive, but I'd have negative terms in the middle when I added them together. When we see a subtracting for the last term, so it could be x squared plus bx minus c, or x squared minus bx minus c. Anytime we're getting subtracting for that last term, that constant, we know that's where we have different signs. One's going to be positive, one's going to be negative. And then depending on what's in the middle, we got to figure out which one's going to make sense for each of those pieces. Okay? But that's going to be a good thing to refer back to, is just how do I set up my pieces in the first place so I can have the right signs, and then I focus on the numbers. All right, so now we're going to focus on the number part. Okay? So for this first one, it's addition and addition. So our rule up top says it's going to be plus for both terms. And for right now, all of our first terms are going to be x squared, which means I'm always going to have an x and an x. I don't have to worry about any numbers with my x's right now. I'm just focused on the numbers in the rest of the problem. All right, so we need to figure out what two numbers are going to go in this blank. We want them to multiply to give me 3, but they add to give me 4. So we're thinking about, okay, what different numbers could I multiply to make 3? But remember, those middle terms get added together, so I need two numbers that add to give me 4. Well, in this case, it's pretty straightforward. About the only thing I can think of to multiply to get 3 is 1 times 3. So 1 and 3. Let's check to see if we did it right. So x times x is x squared. And then I'm going to do my 3x. I'm going to do 1 times x, and then 1 times 3. Yep, that did give me x squared plus 4x plus 3. So what we're thinking about is what multiplies to get c, but adds to get b. So what multiplies to get that number, because my last terms multiply to get the c, but they have to add in the middle, because there's going to be 2 of them, to give me b. So next one. Again, we start with our signs. We know they're going to be x and x. They're both pluses, so I know they're both going to be addition. So now I do the thinking part. I focus on the 32. Think of what kind of things could I multiply to get 32. Well, I could do I could do 2 times 16. I could do 4 times 8. I could do 1 times 32. Which of those combinations adds to give me 12? Well, 4 and 8 are going to add to give me 12, so those are my 2 pieces. All right, next one. R squared minus 3r plus 2. So this time, they both add, I have a positive for my last term, so I know they're going to have the same signs, but I have a negative in the middle, so I know they both had to be subtracting, because I want 2 negatives in the middle, but a negative times a negative gives me a positive for the last one. So start with your last term, c. What could I multiply together to get 2? Well, I can really just multiply together 1 and 2. Do those add to give me 3? Yeah, so I know that they're going to work. 1 and 2. Again, we can check it real quick. X times x is x squared. X times negative 2 is negative 2x. Negative 1x and positive 2. So x squared minus 3x plus 2. It worked. All right. So now we're going to start to mix it up a little bit. So this time, my last term is a negative. So remember, our rule says if it's a negative, that means I had different operations. I had one that's adding, one that's subtracting. And it doesn't matter which of those you write the adding or subtracting in. I just tend to always write my addition one first. So now, when we think about it, I need numbers that multiply to give me 6. So I could do 1 times 6, or 2 times 3. But because they have different signs, they're going to get subtracted from each other. So I need numbers that subtract to give me 1. Well, the only combination that's going to subtract to give me 1 is a 2 and a 3. All right, here's where we got to do just a little bit of thinking. We got to figure out which one's the plus and which one's the minus. Well, I ended up with a negative 1. So I want the bigger number to be negative, because when I combine them together, I still had a negative as an answer. So I'm going to put the 3 with the minus, and I'm going to put the 2 with the plus. That way, when I do that middle term, I'm going to get a positive 2x, but a negative 3x, which gives me that negative 1x in the middle. Okay? All right, so number 5 is going to look a little bit different. Notice how it's not just x squared. I've got a 2 there. Well, think about what we did in an earlier lesson. Is there something that I could divide out of all 3 of those terms? Well, they all have a greatest common factor of 2. So I can factor a 2 out of each of them. And now I have something a little more appropriate for what I've been working on. Okay? So now I focus on just what's in my parentheses. The last term is a negative, so that tells me my signs are going to be different. X plus something and x minus something. I need something that's going to give me 21. Well, I can do 1 and 21. I could do 3 and 7. Because they have different signs, I know they got subtracted from each other and got me a negative 4. So which pair could I subtract and get a negative 4? Well, that's got to be my 3 and my 7. Now, let's look at it a little more closely. I want a negative 4 in that middle term. So one's going to be positive, one's going to be negative, but when I combine them together, I got a negative. So that means my bigger number needs to go with my subtracting, my negative, and my smaller number goes with my addition. So that way I would get x squared minus 7x plus 3x minus 21. And those 2 in the middle would give me my negative 4 that I'm looking for. All right. Oh, sorry, I clicked too soon. All right. Last one together. So nothing to factor out, so I can go right to my binomials. I've got x and x. The last term is an addition, so I know that they have the same signs, but my middle term is subtracting, so I know that they must have been subtractions instead of additions. All right, so focus on C, the last term. What could I multiply to get 121? Well, the only one I really know other than 1 and 121 is 11 times 11. We want them to combine to give me 22. Well, 11 plus 11 really does give me 22. So my 2 binomials are x minus 11 and x minus 11. All right. Hopefully that gives you a little taste for factoring polynomials. We're going to try some on the next page to work on it, but this will be something we work on over the next couple of days. So don't feel like you need to be an expert at it quite yet.